Assalamualaikum warahmatullahi wabarakatuh. And hello guys, my name Muhammad Sharifuddin bin Muhammad Zaidi, nombor kad matrik 01 DKA 19 F2002.
Hi guys, my name is Nirjun Sarvai, son of Balasanta. I'm a student from Civil Engineering Department. My metric number is 01 DKA 19 F2010 and I'm from DKA 2A.
Hi guys, my name is K. Salman, son of Gunarajan. Metric card number 01 DKA 19 F2028.
Hi, my name is Muhammad Imam Fitri bin Zaidi with number metric 01 DKA 19 F2020. Introduction of application of differentiation. Differentiation can help us solve many types of real-world problems by using the derivative to determine the maximum and minimum value of particular function. As example, differentiation can help us find the cost of profit and loss in finding the cost of building. And another example, differentiation can help us find the strength of value of amount of material using in the building. In differentiation, we must mastering the second degree of differentiation and the first degree of differentiation. If not, we can use the application of differentiation.
Hello everyone and welcome to my teaching lesson about the application of the differentiation to solve the problem that faced by all the engineering students. Before we go to the teaching lesson, why not we get some information about the minimum and maximum point in the differentiation. Okay guys, there are three types of stationary point in the differentiation. First one is maximum point, second one is minimum point, and the third one is point of inflection. But today we are going to tell about the maximum point and the minimum point. First one, maximum point. Consider what happened to the gradient at the maximum point. As you can see in the diagram below, it is positive just before the maximum point, 0 at the maximum point, and negative just after the maximum point, which means the value of dy over dx is decreased, so the rate change of the dy over dx is respect to x is negative. The second one is minimum point. As you can see in the diagram below, just before minimum point the gradient is negative, at the minimum gradient is 0, and just after the minimum point it is positive, which means the value of dy over dx is increased, so the rate of change of dy over dx is respect to the x is positive.
Okay, now I want to give some question, and the question is find the coordinate of the stationary point y equal to x minus equal to x power of 3 minus x power of 2 and minus 2x. Okay, and determine the nature of stationary point. Here and sketch a relate graph in a group of 3 or 4%, 3 to 4%. Discuss and carry out a presentation based on application of differentiation to solve the problem given. Okay. Okay. Y equal to x power of 3 minus x power of 2 minus 2. Okay. Dy over dx equal to 3 in bracket x power of 3 minus power of 1 minus 2 in bracket x power of 2 minus power of 1 minus in bracket 1 minus in bracket 2 and minus in bracket x and power of 1 minus power of 1. Okay, dy over dx equal to 3x power of 2 minus 2x power of 1 minus 2x power of 0. Okay, dy over dx equal to 3x power of 2 minus 2x minus 2 in bracket 1. Okay, dy over dx equal to 3x power of 2 minus 2x minus 2. Okay.
So in the step 2, to solve the problem, we need use the calculator in this step. In this step, we need to write the using calculator in the calculation on the paper as a proof of how we get the answer in the calculation. So the purpose of this step is to get two coordinate of stationary point which is x1 and x2. So how to calculate it with calculator?
First, we press mode 1 in calculator, then equation, then press 1 and then scroll the right, then press degree 2, and the final step in this process, put the value A, B, C. So how we get the value A, B, C? So the value A, B, C we can get from the equation of first degree of differentiation, which is 3x squared minus 2x minus 2. So then the value A, B, C is 3x squared, which is pressed in the calculator is 3, then B is minus 2 and C is minus 2. So then we get the xy is 1.22 and x2 is minus 0.55.
Okay guys, we are going to the step 3, which is replace x1 and x2 in the y, which means you should substitute the x value in the y equation. As you can see the calculation, when x equals to 1.22, the y will be like 1.22 power of 3 minus 1.22 power of 2 minus 2 bracket 1.22. You don't forget put the bracket while using the calculator to get the perfect answer, and the answer will be like y equals to negative 2.11. It's actually a coordinate, so it will be like said like when x equals to 1.22, then the y equals to negative 2.11. Okay, when x equals to negative 0.55, the y will be like negative 0.55 power of 3 minus negative 0.55 power of 2 minus 2 bracket negative 0.55, and the answer will be like y equals to 0.63, and when x equals to negative 0.5, then the y equals to 0.63. So the coordinate is 1.22, negative 2.11, and negative 0.55 and 0.33 is the stationary point. Followed by the step 4, which is do the second order differentiation, which means we need to change the dy over dx into d power of 2y over dx power of 2. As you see the calculation, dy over dx equals to 3x power of 2 minus 2x minus 2 will be changed into 2 bracket 3x power of 2 minus 1 minus 1 2x power of 1 minus 1 minus 0, because when we do the second order differentiation, all the power will be bring in front, and the 2 will be get 0 because it don't have any unknown, and we will get 6x minus 2x power of 0. As we know, x power of 0 will be 1, so we get 6x minus 2 bracket 1. The final answer will be 6x minus 2.
Now we will move to step 5. Replace the value of x1 and x2 in the second order equation. When the x is 1.22, we will replace it in the second order equation. After replacing it in the second order equation, we will get the answer 5.32. When the x is negative 0.55, we will replace it in the second order equation. After replacing, we will get the answer negative 5.3. Step 6. Write down the maximum and the minimum point. Maximum point is negative 0.55 and 0.63, and the minimum point is 1.22 and negative 2.11. Step 7. Sketch the related graph.